Hi everyone, we will discuss array techniques for reducing time complexity. These array techniques are we are going to discuss prefix sum, subarrays, sliding window and carry forward. Let's discuss one by one. Each technique helps us reducing time complexity. Now first prefix sum. Let's take an array. Let's take elements 1, 2, 3, 4, 5. Now what is mean by prefix sum? So for first element the prefix sum we can write as 1, but for 2 the prefix sum is the previous elements we will add, that is 1 to 2, that is 1 plus 2 3. For the 3 the prefix sum is the previous everything we will add, 1 plus 2 3, 3 plus 3 6. Similarly, for the prefix 4, we will add everything. That is 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. And for the 5, we will add from the starting everything. That is already up to here. It is 10, 10 plus 5, 15. So now let's write the code for this. We will take an array prefix of size n, which is the same as our array n. And now first p of 0 will be a of 0, the first one. But after that we will do p of 1 is a of 0 plus a of 1, right? P of 2 is a of 0 plus a of 1 plus a of 2. So this can write as a of 0 is already p of 0. So it is p of 0 plus a of 1. And here up to this it's already p of 1. So it is p of 1 plus p a of 2. So we can write in generalized way p of some I is equal to p of I minus 1 plus a of I. So this way we can construct our prefix sum. So let's run this on the editor and let's check how the output is going. And I'm taking the same code, I'm running on editor. So here I'm running. So I'm taking 1 2 3 4 5. So first it is 1, then 1 plus 2 3, then 6, then 10, then 15. We have constructed the prefix sum. So the code, the logic we have already discussed. So next we will discuss what is sub array. Now what is sub array? If you take any array, for example, if you take an array 1, 2, 3, 4, 5. So sub array means it is a continuous array in itself. For example, 1 is subarray, 1 and 2, 1, 2, 3, and 1, 2, 3, 4, and 1, 2, 3, 4, 5. And we will take 2 because it should be continuous. We can take 2 is a subarray, 2, 3 is also subarray, 2, 3, 4 is also subarray, 2, 3, 4, 5 it is also subarray. Now 3 is a subarray, 3 comma 4, 3 comma 4 comma 5. If you observe, it is like the start and the end. The start, the end, you can observe for the prefix here. So we can use the prefix sum approach here to solve this. The code we will write printing this sum of all the sub arrays. That is how we will do. We will do the same as we'll construct a prefix sum. The same code we will construct. Then using prefix sum we will solve this printing the sum of all the sub arrays. So how we are going to do, we will take from I equals to 0 to I is less than n, and I plus plus, then j is equal to I, j is less than n, j plus plus, and we are taking here, if I is equal to 0, it is p of j, and if else, it is p of j minus p of I minus 1. I can explain this code. For example, uh in if you take 1 comma 2 comma 3 comma 4 comma 5, so first sub array is 1, so I equals to 0. When I equals to 0, j equals to 0, and j is less than n. And when if I equals 0, we are printing p of j, that is 1. And next time we are taking this next the prefix of j as 1, and then prefix of 1 as sum of 1 and 2. So that is what subarray. 1 comma 2 is a subarray, we are printing that sum. And 1 2 3 1 subarray, we are printing that sum. 1 2 3 4 that sum subarray, we are printing that sum. 1 2 3 4 5 5 up to this, we are printing that sum. So after I, if not I equals 0, when I equals to 1, we will take p of j. For example, prefix of this 1, and we should delete the previous one, so p of I minus 1, that is 0. Like that we will take. I am printing all the sum of subarrays. I will show that code, and I will run that code in editor. You can check the code, and you can check the same logic here. I'm running the code here. So I'm taking 1 2 3 4 5. The first sub array is 1, so it is 1. Second sub array is 1 comma 2. The 1 comma 2 sum is 3. Similarly, 1 comma 2 comma 3, the sum is 6. 1 comma 2 comma 4 up to 10, the total 15. After 1 2 this coupled, because sub array means should be continuous, and there should be start and end. So that the sub array is 2, I'm taking 2. That the sub array is 2 comma 3. The 2 comma 3 sum is 5, and 2 comma 3 comma 4, that sum is 9. So like that I'm taking. No. Next we will discuss sliding window. Sliding window is a very popular algorithm. It is very useful in reducing time complexity. Now, let's take array. Let's take an one array and let's do that. One, two, three, four, five, six. No, what my task is printing. For example, some a fixed pot. s- For example, I will give example. For example, k equals to 3. I should print sum of that k equals to 3 subarrays. I have to print sum of the subarrays whose size is 3. Now 1 comma 2 comma 3 and 2 comma 3 comma 4 and 3 comma 4 comma 5 and 4 comma 5 comma 6. This is the subarrays whose size is 3. Those size sum I have to print. So for that, what I am doing is, if you observe, at start you are just taking, I will write the logic itself here. For I equals to 0 to I is less than 3, I plus plus, you are taking the sum is equal to sum plus a of I. So first this sum we have print, that sum equals to 1 plus 2 plus 3, that is 3 plus 3, 6. Now what we are going to do is, we already calculate this sum, so I want to calculate this sum. So what I am doing, already in this sum I will delete 1, that is in this sum I will delete 1, that is a of 0, and I will add this one, a of 3. So like that, sum, the next time also I will repeat the same, a of 4 and sum is minus a of 2 plus a of 5. So the logic for this is, up to there is some start and end. First the start will be from the 1 and the end is 3, and the logic is, I will take while loop and end is less than a dot length, and I'm just taking the same, the sum is equal to sum minus a of start minus 1 plus a of end, and I'm just start plus plus and end plus plus. If you didn't understand this logic, just watch at the code. The same logic I have applied here, and you can just observe the same logic in this code just we have discussed previously, and you can do your own analysis, and even you can write your own code based on your observations. So here, by sliding window I'm printing. First, if I have to print the sub array whose size is 3, means 1 plus 2 plus 3, that is 6, then 2 3 4, that is 9, then 3 4 5, that is 12, then 4 5 6, that is 15. Why it is called sliding window means, it just sliding. First 1 2 3 I'm taking, then 2 3 4 I'm just removing 1 and adding 4, then 3 4 5, and again I'm adding 2 and adding 5, and 4 5 6 I'm removing 3 and adding 6, so it's just sliding. So if you observe the time complex is space complex, the best you can observe, other than if you solve the one. The last one we will solve is carry forward. Carry forward is also just very simple, like prefix sum. I will take array 1 3 2 5 1. So carry forward, what is means, for example, if I take 1, this is if you see from the left side onwards, it is a maximum, that is 1. I will give the clear explanation. So if you observe 3 from the left onwards, the maximum is 1, up 1 or 3 is 3. If you observe from 1 to 2, the maximum element is 3. If you observe from left to right up to 5, the maximum is 5. If you observe from left to right onwards, the maximum is 5. That like we are doing left to max of that. So just like prefix sum, we will take that left to max array of size same, and 0 is equal to left max of 0 is 0, and left to max of, you can observe the code, left to max of 1 is equal to, how can write, that is maximum of left to dot max of that previous one, that is 0, or a of 1. So even left to max of 2 is equal to maximum element of left to max of 1 and that a of 2. So you can write as left max of I is equal to max of left max of I minus 1 plus a of I. So I have already written this code. I can just take this code and run here. So actually here, so up to 1 1 is the maximum, up to 1 3 3 is the maximum, 1 3 2 3 is the maximum, 1 3 2 here 3 is maximum, up to 5 5 is still maximum, up to 1 5 is maximum. So it is a new array. So you can check the all the codes by pausing the video. I have discussed these array techniques, like sliding window, carry forward, sub arrays, prefix sum. These array techniques will definitely helps in saving time complexity and space complexity.